Hi, everyone. Welcome to part 2 of Chapter 11 Area Review. So problem number 13 says the diagonals of a rectangle are 8 units long and intersect at a 120-degree angle. Find the area of the rectangle. So let's see, we're going to make a rectangle. And the diagonals are 8 units long, so there's 8. And the neat thing about rectangles is that not only are their diagonals equal length, but they are bisected. So of course, then 8 becomes then 4. Couple of things here. We know that this right here is 120 degrees, which would mean that's 60, because that's 180 degrees for a straight line. That would make this 60 right here. If I split this up and divided that in 2 and made that perpendicular, check, that would be 30 degrees. And now I have a 30, 60, 90, and I have one of my sides, which is opposite the 90, which equals 2a. So that means a is 4. So a is across from the 30, so that's going to be 2. And a root 3, so 2 root 3 is across from the 60. Now, keep in mind, if from here to here is 2 root 3, then this is also 2 root 3. So 2 root 3 plus 2 root 3 makes my side length 4 root 3. And if that's 2, because these are congruent, that makes my height 4. So if my area of a rectangle is equal to base times height, and my base is 4 root 3 units, and my height is 4 units, that's going to be 16 root 3 units squared. That's my area of my rectangle. Okay. Draw a square, and it's inscribed and circumscribed circles. So let's draw a square, or let's draw a circle first. Find the ratio of the areas. Okay, so drawing a circle, we need to make a square inscribed in it. And then another circle inside of that. Remember that your circle's got to touch all the corners, or all the sides anyways. We don't have any other information except that we want to find the ratio of the areas, which basically means we're going to find pi r squared to pi r squared. We don't have a length, so I don't know, let's just call this side length x. And so therefore, this right here, which is halfway down the square, would be x over 2. Then if I went to the corner here, that's a radius. So that's the radius of my small circle. And here's my radius of my large circle, because it goes out here and touches the corner. So if that's x over 2, that side is x over 2, which would make that a 45, 40, or a 45, 45, 90. So that's going to be x over 2 root 2. So the area of my small triangle is pi r, which is x over 2 squared. And the area of my large circle is going to be pi r. In this case, my r is x root 2 over 2 squared. So this is going to make x squared pi over 4 to, this is going to be x root 2 times x root 2 over 2. So that's going to be x times x, which is x squared. Root 2 times root 2 is 2 over 2 times 2, which is 4. 2 will cancel, and so I have x squared over 2 pi. So x squared over 2 pi. Now, remember that when you're making a ratio, that's also another way of writing it is a division. So we can also write this as x squared pi over 4 divided by x squared pi over 2, in which case it's x squared pi over 4. See this division? When you're dividing, you can also multiply by the reciprocal. So that's going to be 2 over x squared pi. So what ends up happening is we're able to cancel out our x squareds. X squared divided by x squared is 1. Pi divided by pi is 1. 2 divides into 2 once, and 4 twice. 1 times 1, 1 over 2. You also could rewrite that as 1 to 2. And that's your ratio of areas. An isosceles trapezoid with base lengths 2 and 6 and leg lengths 4 is circumscribed about a circle. Find the area of the region that lies inside the trapezoid but outside of the circle. Well, let's see. Let's make a circle first. And we have a trapezoid that is circumscribed about that. So try to make it so that it touches there once. I'm going to try to lift that up just a little bit. There we go. And, well, does this, and this. So pretty much your circle has to touch all the sides. Okay, so there we go. So we have our trapezoid. So what they're looking for actually is this area that's in here, that's outside of the circle, but still inside of the trapezoid. So they're looking for all this space inside. So our plan of action is to find the area of the trapezoid minus the area of the circle. So we're going to go height divided by 2 times the sum of the bases minus the area of the circle, which is pi r squared. So a couple of things. We need the radius, we need the height, we need the bases. So what did they give us? They gave us base lengths of 2 and 6. So here's 2 and here's 6. Leg lengths of 4. So find the area of, okay, so what I would do is I think I would bring this down to make a right triangle there. And also, of course, it's mirrored here. If this whole length is 6 and this is 2, that would make this 2 and this 2 also. So to find this third side, to me, actually, if this is A and that's 2A, this is a 30, 60, 90 triangle. So here's 30, 60. So that's across there is 2. That makes this 2 root 3. So that's my height. So let's see what we've got. We've got 2 root 3 divided by 2 times the sum of the bases, which is 2 plus 6, minus pi r. So now I actually need the radius. So to find the radius, I think all I need to do is to draw from here to here. Well, if this whole length is 2 root 3, this little part right here is just root 3. That's double. So my radius being root 3 squared. So what do we have? We have 2 cancels with 2. 6 plus 2 is 8. So we have 8 root 3 minus root 3 times root 3 is root 9, which is just 3. Whenever you square a square root, it just what's inside is what your answer is. So we have 3 pi, so minus 3 pi, parenthesis, units squared. So that's the area of the area that's the area of the shaded region. Basically, that's outside of the circle, but inside of the trapezoid. The side of a square is 8 units. Find the circumference of its inscribed circle. So another square. And we have a circle inside. Okay, so again, it's got to touch all the circles, or all the edges here. All right, we know that the side is 8. So that means that's 4. That's 4 also. Find the circumference of the inscribed circle. You know what? A lot of people make a mistake and they do this. They take their radius and they go to the corner. And they're like, well, how do I know what the radius is? So I understand the wanting to do that, but don't do that. That's not helpful. That's the radius of the square, but they don't want that. They want the circumference of the circle. So the circumference of the circle is 2 pi r. So that's 2 times pi times my radius, which is 4. So that's going to be 8 pi. So that's the circumference of my circle. Okay, that's it. This question says, find the circumference of the inscribed circle. Is that the same question? Or a circumscribed circle. So what they want, find the circumference of its circumscribed circle. So circumference equals 2 pi r. And so that's what we were talking about. So that's going to be 2 pi times the radius. Well, the radius is this. So that's going to be this length that we just drew. And so what we're going to do is we know that that's 4, and that's going to be 4 root 2. And so therefore, my radius is 4 root 2. So circumference equals 8 pi root 2. All righty. The side of an equilateral triangle is 12 units. So if you have an equilateral triangle, let's draw that. You know all the bases or all the angles are 60 degrees. So one side is 12. So we know that's 12, 12, and 12. Okay, so find the circumference, of the inscribed circle. I need to draw that. So you're going to draw a circle inside. And what you need is a circumference. So circumference equals 2 pi r. So we know that the distance from here to here, right there, is 6. Okay, so what we can do is we can draw this right here. We know this is 30, and we know that's 60. Okay, so across from the 60, I'm going to come over here. Across from the 60 is a root 3. So if a root 3 happens to equal 6, then a is equal to 6 over root 3. But you're not going to leave a root on the denominator, ever. So we're going to multiply by root 3 over root 3. So we get 6 root 3 over 3, which ends up being 2 root 3. So our little apothem here, which is across from 30, ends up being 2 root 3. So remember, that's my circumference. So that's my radius. So I just say 2 pi, and my radius is 2 root 3. So that's going to equal to 4 pi root 3 units. Not units squared, just units, because it's circumference. We're finding a length, not the area. And then you need to find the circumference of the circumscribed circle. So for this problem, you've got circumference is equal to, let's see here, 2 pi r. So we go 2 times pi times this one, which is going to be 3 and 3 is 4 root 3. So that becomes 8 root 3 pi. And it's okay to put the pi on the outside. I like to write it like this, 8 pi root 3.